Alright, I'm going to make an attempt here to video one run through this dialysis demonstration so that those that aren't here today can participate. So the first thing I want to do is identify all of the solutions that we have that we're going to use for the demo. We have a concentrated solution of iodine, concentrated solution of starch, and you can see how cloudy it is. Concentrated solution of sodium chloride. There is a lot of sodium chloride dissolved in here, even though you can't tell, but it's unbelievable how much sodium chloride, how well water dissolves sodium chloride, salt. We've got a conductivity probe to measure the conductivity of the solutions that we're testing, and you can see that there is some conductivity here. It's 322 to 323 milligrams per liter, give or take, and that's just tap water. So that shows you that there are some things dissolved in the tap water. What the conductivity is measuring is the potential of the solution to conduct electricity. And a solution that has ions in it, things dissolved in it, like sodium chloride, will cause the conductivity to increase. And that's how we're using it. We're using it as an indicator that sodium chloride may be diffusing into the solution. We've got dialysis tubing, and this is the main player in our experiment. We're using the dialysis tubing as a stand-in for a cell. And this is dialysis tubing that's been soaking in water. It's tied at one end to create a bag, and then I'm going to place the solutions into the bag and seal up the other end, and then place that into the beaker that's going to have an iodine solution in it. The way I'm going to measure the solutions out is with this graduated cylinder. This is what dialysis tubing looks like before it's soaked in water, and you can probably hear and see that it's very crinkly, and it's just like a piece of plastic, and you wouldn't even know that it's actually two layers, but there are two layers here that can be separated, and that's how it can form a bag. And then we've got a dialysis tubing clip, which is nothing more than a piece of foam with a slit in the middle so that you can use it to seal up one end of the dialysis tubing. I sealed up one end with a rubber band because it's more reliable than these clips, but these clips are a lot faster and easier, so I decided to use them for demonstration purposes. Alright, so all we're doing here is measuring out 10 milliliters of starch solution, 10 milliliters of sodium chloride solution into one dialysis bag, sealing up the end and placing that into a solution that we're going to create by adding iodine. You do need to record this initial conductivity for the tap water, so about 322. It's going from 321 to 323, so you might as well just go ahead and record 322. In the meantime, I'm trying to separate the end of this dialysis bag. It can be difficult sometimes because it's slippery, and yeah, there it goes. So now I've got the opening open. You got to blow into it to make sure it's completely open. And next I'm going to measure out, let's measure out the sodium chloride first. Measure out 10 milliliters of sodium chloride solution. Again, this is pretty highly concentrated. It's almost saturated, at least at room temperature here. So drop by drop, measuring out 10 milliliters. It doesn't have to be absolutely exact for demonstration purposes. And then pour that into the dialysis bag. So there we have our sodium chloride solution in the dialysis bag. Now we do the same for our starch solution, and it's okay to use the same graduated cylinder because both solutions are going to the same place. (10 milliliters of starch solution). So there's our solution in the bag, and that's one of the things you need to note is the color of the bag now. So you can see very clearly the cloudy color tells you that there there is starch solution in the bag. There's no indication of sodium chloride in the bag, but you need to take my word for it that this is a concentrated solution of sodium chloride that we've just added. So now we fold this over a number of times and twist it, and fold it over again. Place a clip on it, the foam clip, to keep it closed. So again, you should have recorded the conductivity of the water here at about 322. I'm going to take the conductivity probe out. Oh, and before we place it into our beaker, I'm going to add the concentrated solution of iodine, and I'm just going to squirt some in here. I'm not going to measure it out. I'm just going to squirt some in until it's relatively concentrated, but it's still dilute compared to this concentrated solution. This is quite a dilute solution of iodine, but you can see very clearly that there's iodine in the water from the brown color, and that's something else that you need to record, is the brown color, and that's on your table that you're recording it on as outside the dialysis bag. So you're recording what it looks like inside the dialysis bag, the cloudy color, and outside the dialysis bag almost looks like urine. And before we place this dialysis bag into the solution of iodine, we need to weigh it. So I've got a scale here, and I'm going to place a, because when we weigh this the second time, we're going to be weighing it after we take it out of the solution that it's been soaking in for 24 hours, and it's going to be wet, so we're going to need to dry it off. So I'm going to do it the same way both before and after, but you'll see that the paper towel itself weighs 2.32 grams. So I'm going to hit tare here, which is going to zero it basically. It's going to automatically subtract out the paper towel. Lay the dialysis bag on there, and so this is what you need to record is 21.978. Okay, so let's go with 21.98, and the reason for the fluctuation is probably the ventilator and the air blowing down on it, but 21.98 grams. Make sure you include the units, always include the units. All right, so now it's time to go ahead and place the bag into the solution and let it sit for 24 hours. And I'm going to go ahead and hide this so you can't see it for the next 24 hours. We'll get it back out tomorrow and take a look. So that's our part one of the demonstration of diffusion and osmosis. Part one, diffusion and osmosis demonstration.